district that's served. See, it's between Milwaukee and Gladstone. I think the population served is, it's, I want to say 50,000 or 60,000 people. Okay, so this is the old plant, and it was a small, simple plant, high rate activated sludge. It was put in stages. I think it was a primary treatment facility, and then Clean Water Act came in '72, and they probably had to add some secondary treatment to that. So they added aeration basins and secondary clarifiers. So these are the old primary clarifiers, these are the small aeration basins, and these are the old secondary clarifiers, and the digestion tanks here. Okay, just a simple process flow diagram of the old plant. Headworks here, primary tank, aeration basin, secondary clarifier, disinfection was gas chlorine. Here's some just a couple of process parameters between old and new, just to kind of show the different type of treatment plant we're operating. Mixed liquor was real thin, not even 1,000. We're now up to, we're actually now up to like 3,000.
It's 3,000 now.
Aeration detention time at normal dry weather flow. Well, you can see 4 hours in high rate system, and now we have 16. SVI has improved drastically, 230 in the old plant, and down to 100 now. And part of that is just those high rate plants are real intense. Everything happens over a shorter period of time. The bugs are way younger, and DO is higher. Everything is just happening. You just got such a short period of time for the BOD removal to take place. Units that we had in the old plant versus what we have now, it's generally a much bigger facility. The text in the red is the old process unit processes that we still use. So all the black stuff in this column is stuff that's been replaced or mothballed. The red stuff is the stuff that we're still using. And this we're still using the anaerobic digester, but that is going to be taken out of commission as soon as we can use the aerobic digester. There's a few methods by which we're going to achieve this 80% sludge reduction. We've got 4 of them here. First one is simply screening trash out of your mixed liquor stream. So I know you have headworks and you have screens and grit removal, but a lot of material gets through those screens and makes it into your aeration system, and it's very finely ground down toilet paper and rags, so part of the process is continually removing part of the mixed liquor, pumping it to a fine screen, and removing the trash that's in the mixed liquor. If we do that, we should be able to realize just straight off the bat like a 20 to 25% yield reduction just by removing the trash alone. So it's not doing anything fancy, it's not doing anything biological, it's just taking trash out of your mixed liquor, out of your solid stream, and you're going to reduce the amount of solids you produce by 20% right there. We have pumps that take out of our aeration mixed liquor from aeration system, send it to this large drum screen with it's a fine screen, and if we have those pumps working 24/7, then we can turn over our entire aeration basin, and most of it will be, more of it will be degraded.
More of the waste to get degraded.
So let's see here.
More of the time to eat the food,
Our
they eat more.
Is up to
And are
£60,000
better at it.
in our aeration system now. They used to carry much less than that, I think £10,000 maybe. So we're up significantly from then. If our current waste rate is £3,500 a day, then that means our sludge retention time, our SRT, is 17 days, which kind of puts us in that 15 to 40 day range. So we're kind of an extended aeration plant. So we are achieving a lower growth rate, a lower sludge growth rate as a result of that extended timing system. Now our target is a different type of bug. So in a conventional plant, conventional
extended aeration,
is an aerated
increased SRT.
Bugs are aerobic
They're going to
bugs,
reduce growth because they're going to make them
provide
facultative.
food and air, and they'll
less growth.
consume the
And
BOD,
we're going to
the
increase BOD bioavailability.
in the influent stream. So aeration basins. So at the end here, you transfer your mixed liquor into your secondary clarifier, and in this secondary clarifier you have your solids-liquid separation. This is where you produce your clarified effluent, goes over your effluent weirs, and then after disinfection, you're at the final stage of the treatment process. On the sludge side of that, the solid side of that, you're drawing your RAS, your return activated sludge off the bottom of this clarifier, and that will go back to your process to consume what influent you have coming in. The cannibal, say that the difference in the cannibal treatment process is you're taking some of that return activated sludge and you're putting it into an anaerobic tank, and it's going to stay in that anaerobic tank for a minimum of 10 days, and then you're going to cycle it back through into your aeration system. So it's just another loop in the process. It's like an anaerobic side stream, and on a daily basis you're feeding this IBR, this interchange bioreactor, and then you're pushing it back into your aeration system. So the hope being that for the duration it's in here, you get some of that breakdown. Some of those cells will bust apart, and when you decant it back into your aeration basins, your bugs can get at the first step of that solid reduction process that we talked about in the last slide. You pump your mixed liquor into the screen, over the screen, the clear mixed liquor drains back into your aeration system, and the rags and the trash material is separated, stays on the other side, and it drops into a press. It's dewatered and pressed into a dumpster. We are up here, 2 IBRs
We see the aeration basin. It's not going to
clarified
affect the
effluent comes
IPRs.
to your UV for disinfection, and out to the river. This is a quick basic schematic. Again, you've seen it in real life. IPS is here. This is where this is where the collection system comes to a point, and into a large deep wet well. It's pumped up to the headworks, gets its screening, automatic bar screens, and grit removal, and then gravity flows into your aeration system. We have four aeration basins. The mixed liquor from that aeration system is returned to the front end of the aeration basins. That's for nitrification reasons, and we'll talk a little bit about that in a later slide. So that's your mixed liquor return. Portion of your mixed liquor is going to come into your clarifiers. You're going to get your solids liquid separation there. On the sludge side of that, so the underflow, you return your RAS, your return activated sludge goes into the front end for to consume the BOD coming in, and then portion of that is getting pumped up into these interchange bioreactors, spending a residence time in there. Minimum of 10 days is the design, but we have a longer residence time. I think it's about 17 days maybe. And then a portion of that is then returned to your aeration system. So, what we're doing with this, we're just sending some into the aeration system and replacing it with sludge from the clarifiers. And then on the wasting side, we put sludge across the gravity belt thickener. It goes in at, let's say, 1% thickened across the belt to 6%, and we pump it currently we pump it into the anaerobic digester. It gets digested and residence time in there, and then after 40 days or so it's stabilised, and we can draw it off for dewatering and land application. These second half of the aeration basins are aerated. That's like your conventional plant. We have a DO up there of between 3 and 1.5. Conventional plants usually around 2. You want to try and keep it 2 or above. We have 60,000 pounds of inventory up in the aeration basins throughout those 4 basins, and that equates to a mixed liquor concentration of 3,100 milligrams per litre. That's kind of our process target right now, and we kind of revise that once a week depending on what we want to try and achieve. Currently it's 31 milligrams per litre. Aeration basin SRT, so our sludge retention time in the aeration system is 17 days at a current waste rate of 3,500 pounds a day. So what else do we have going on up here? pH, we want to try and keep a close eye on the pH. pH is a permitted, regulated parameter.